Hi, so in this video, we'll solve the exercise reduce everything, which is a higher order function exercise. So let's go over what is a higher order function and how it can be useful. So let me fire up my Python. Higher order function is where functions are treated as data. You can pass functions as data. You can pass functions into another function, or you can return functions from a function, and you can embed functions in data structures. Uh, so let's write a function named apply, which takes a function and bunch of parameters, and it will apply those parameters to the functions that's passed. So I'll define apply, and it takes a function, and for simple I'll take the arguments as this. So this means in Python like variable arguments. So what it does is apply that functions on that arguments, and pretty much that's it. So let me define add. It takes a and b, return a plus b. All right, typo there. So you can add 5 comma 6. We're getting 11. That's what we wanted. So I'm going to apply add on 5 and 6. All right. So there's a mistake. Let me go back here and one sec. I have to return the result. I forgot about that. So when I apply, so I get 11. So what if I do apply like 7 and 8? I get an error. So let me generalize my add to accept more arguments and sum it up, right? Define add, instead of having two parameters, I'll take multiple parameters, and uh, maybe I'm adding, right? Sum, return sum, I for I in args. It's basically a wrapper on sum, but anyway, there's a typo. So let me test this out. Working, working. So I'll apply this with that, and we are applying add and with bunch of values, so we are getting that. So what we demonstrated here is that you can pass functions as data to a function, and it can do whatever it wants with that function. So now let's try. This is some pattern. This I already know. There's something called as n times. So in other words, you pass a number to that function, so it returns a function which takes a parameter and it multiplies n times that you had passed earlier. The way to do that is n times takes a number, takes a function and a number, uh, right. I'm just thinking, I guess I gonna take off this, just takes a number, uh, and then it returns a function. uh, Let me just define func takes a number and returns a into number, or maybe better, finds this is number, sorry, and times into number, and you return that func. So what I did there is I take now times as an input and a function that returns, a function that takes a number and it multiplies with that times, and the n times returns that function, so you can use the function later on. So double equals n times twice, or number 2, so it multiplies with 2 for the number that we pass to double. And when we call double with 5, we get 10. So this is higher order functions. So in next section, we'll solve the reduce everything exercise from CS Primer. So welcome again. If you have subscribed to this, you should be able to download the file that I have and a good walkthrough. So I have the file here. It's written in Python. In the end, the doc tests are run. So there's my zip, my filter, my map, and a product, and doc strings here. So I'm gonna solve one by one. So I'll comment all of these for now. Open up one more terminal. cd learn CS Primer, programming, beyond the basics, and higher order function, cd reduce, Python reduce.py. So it's failing, which is the reduce. So let me go ahead and try implementing reduce. So I won't be working with iterators for now, so I'll be just using the list. Let's go with that. So there's initialize in it, which is or maybe, right, so if length of excess is 0, return init. If no length, I'm just gonna return init. So here that I know that there's some elements in init. If init equals none, init equals xs of 0 and xs, I'm doing a mutation here, xs is 1 till the end. This is called a slicing in Python. More about that later. So for x in xs, so what I'll do is call the function, which is function. I have to pass init, which is the accumulator, and x, and store that in init. That's a bad thing. Or maybe just I would do like accumulator is the init, and I would store with accumulator and return that accumulator. Yeah, this I'm happy with. So let's just try out the dog tests. Right, something's not working. So let me just try out Python minus I reduce dot py. Okay, reduce. Function is lambda. Uh, what is that? Accumulator nx should get return this and uh 1.2.3.4. Right, something is not working. If init is none, init equals the first element. If not, why am I not getting that? So there's a function and excess, which is the list, and init none. So I'm not sure why it's not working. Uh, accumulator equals f of init comma x. That gives you accumulator, and then in the end you return the accumulator. All right, so let me just print out here init and excess. Okay, okay. What's happening? Why it's not calling? Hmm. Okay, define reduce. So let me just try out like printing something here. All right, so I haven't saved this, so I'm such a. It's fine. So now that I've saved, let's just try this out. Okay, it's coming in, printing the things out. It's giving me as 5, which is a wrong answer. Uh, I think it's 6 plus 4 is 10. Let's just track it down. If init is none, yeah, excess mutates, which is fine. So accumulator is init for x and okay. Right, so I'm gonna print accumulator. Okay, so I'm passing init. Uh, it's a mistake from my side, so I should be passing that as accumulator. And let's try this out. Wait a minute. Let's just drag this thing down again. Okay, maybe I should have saved. Alright, so Redis is done. We got that. So let's just uncomment the product. So init is 1, but I'm not sure why it's not running the test. Maybe I'm missing something. Okay. Expected 1, got init 1. Alright. Okay, so I'm gonna save this again. The product is done, so let's move on to map. So filter is a function that takes a function which is a predicate function, means that it either returns true or false for a given input, and uh, filters out whatever the bunch of values that it receives. So if it passes the uh, function that it has received, so it just collects them, the rest it ignores. Right, so the way to do this is result is an empty list, and for x in xs, if f of x, which means it passes, so just do result dot append of x, and in the end return result. I think it should pass, so let's just try that out. Done. So let's just move on to myzip. So zip takes bunch of iterators, and what it does is take the first element from each of those iterators, or maybe less in this case, or anything like a tuple or anything that iterates, right? So it combines them and gives you as a packed value. And excuse me for a moment here. So yeah, it combines those values and returns as a tuple. And yeah, so let's just try that out. So not sure how to approach this, so I have to think a bit on here. Okay, here it says it's of same length. So what I would do is, I'm just assuming it's not robust right now. So I'm assuming that all the iterables have the same length. So for I in range, uh, so if length of iters is 0, return none, return this, right? For I in range of iters of 0, that should be a length, sorry. Uh, so I'll get a result as this, and for x, for iter in, that's a taken thing in the Python, it's a keyword. For iter in iters, result dot append uh, iter of I, and yield that result. So this also makes a myzip iterator. So we'll dive in what is yield and iterators later on. So this should work. Hopefully, let's just try that out. And just like that, we did solve uh, the reduce exercise. So this is bare barely functional. It's only working with lists. So we need to extend this to work with all kinds of iterators. So we'll coming to that in maybe in next session. So until then, take care.